All right, so this section is on exponents, and actually might be one of my favorite sections. So when you're trying to solve these, what you have to do is you have to make sure you're rewriting them using the same base, okay? So for instance, let's just dive in. So here's a base of a 3 and a base of an 81. So usually the smaller number might give me a clue of what to think for my base. So let's think about all the 3's. So I'm going to think about my 3's. So 3 to the first is 3. 3 squared is 9. 3 to the third is 27. And 3 to the fourth is 81. Oh, okay, so here we go. We've got a winner. So I can leave this 3x and then 3 to the fourth. And as soon as the bases are equal, then you can set the exponents equal to each other. So then that turns that into x to the fourth. Okay, so the next one, I have 2 for a base and 16 for a base. And like I was saying, a lot of times the smaller number will at least give you a hint. So let's think about our 2's. So 2 to the first is 2. 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16. Okay, so we have a winner. So I'm going to rewrite this as 2 raised to the 3x minus 8. And then 16, I'm going to write as 2 to the fourth. Okay, then as soon as your bases are the same, you can set the exponents equal to each other. Okay, so then add 8 to both sides. I get 3x equals 12, divide by 3, and x equals 4. Okay, then this one, and like I said, sometimes the smaller number will give you a hint. Okay, so 9, then 9 squared, so that's not going to work. But if you think about what we just did over here with the 3's, let's see, 9 could be written as 3 squared. 27 could be written as 3 to the third. Okay, so let's rewrite that. So 27, I'm going to write as 3 to the third, then x plus 3, and then 9, I'm going to write as 3 squared, x minus 1. Okay, then you're going to distribute this 3, distribute the 2. So then you're going to have 3x plus 9 and 2x minus 2, and then just solve for x. Okay, so then I'm going to subtract 2x off of both sides. So x plus 9 equals negative 2 minus, Daryl, she's knocking at the door, equals negative 11. Okay, so x equals negative 11. Okay, then the next one, let's see. I told you sometimes the smaller number will give you a clue to what base to use. Shh. So I'm going to think about 5. So 5 to the first is 5. 5 squared is 25. 5 to the third is 125. Okay, so let's rewrite that. 5, 3x minus 6, and then 125 I can write as 5 to the third. So as soon as my bases are the same, which they are, I can just set the exponents equal to each other. So 3x minus 6 equals 3. Then add 6 to both sides. So 3x equals 9. Divide by 3. And x equals 3. Okay. Ooh, this one looks weird. Okay. So I need to, I've got 7's in both of them, but I'm just going to need to rewrite this square root as an exponent. Okay, so I've got 7, and that is supposed to be raised to the x minus 2 over 6. And then remember, square root can be written as the 1/2 power. So now I do have them with the same base, so I can set the exponents equal to each other. Okay, then I can cross multiply. Gosh, I wish I didn't have that written right there. No problem. Okay, so now I've got I've got 2x minus 4 equals 6. So add 4 to both sides. And I've got 2x equals 10, divide by 2, and that would be x equals 5. Sorry that it's really squished in there. Okay, all right, so now 8 and 4. But if you think about this problem that we just worked, 8 could be written as 2 to the third, and 4 could be written as 2 squared. So let me rewrite that. So that's going to be 2 to the third, x plus 6, 2 squared, x minus 3. And then I'm going to distribute this. And I would have 3x plus 6, 2x minus 6, okay? Then subtract 2x, subtract 2x. I've got x plus 6 equals negative 6, subtract 6, and x equals negative 12. Okay. Then on the very next page, I'm going to do at least 2 pages together, okay? It says using logs to solve exponential problems. So now, because there's no way to rewrite 134 as 5 to some power, okay? If I've got a base that is not 10, okay, so like this is a 10, but this one is not a 10, then I'm going to use natural logs to solve this, okay? So I'm going to put a natural log on this side, so natural log of 5 raised to the x, and a natural log of 134, okay? So then, remember your power is brought to the front. So now I really have x ln 5 equals ln of 134, okay? I'm trying to get x by itself. So I'm going to divide by ln 5 on both sides. What's 5? Okay, so then I get x equals ln of 134 over ln of 5. Now later, you can literally type in, if you've got a calculator that looks like this, you'll notice that like here is the log button with a 10 to the x. Here's an ln button with an e to the x. So later, some of your questions may want you to go all the way down to a decimal, and that's how you would do it, is by using that ln button. But this is just having a simple 5. Okay, so the next problem is a base 10. Okay, so I'm going to use log base 10 on both sides. Log base 10 on both sides. And the great thing that happens is when you do a log base 10 with a 10, that portion's going to cancel. Okay, so that will cancel. It'll take that exponent and bring it on level, basically. And now you've got log base 10 of 8,000 as your answer. And you could type that into calculator to get like a decimal answer, but that's not what it's asking at this point. Okay, so now, before we can solve for this x, we are going to have to log base e 0.6x minus 3. We're going to have to add 3 to both sides. I shouldn't have written that 2 times. Okay, so plus 3 plus 3. Okay, so 40 e 0.6x equals 240. All right, so now divide by 40. And we're going to get e to the 0.6x equals, and you should remember that you can knock off those zeros off the end. Now 4 goes into 24 6 times, okay? So now what I have left is e, and the thing that is going to cancel e is ln. So if I do an ln on both sides, okay, so that's going to cancel and bring the 0.6x down on level, and then ln 6 would be, you can type it in, it would be ln of 6, like has a value. There's no reason to, there's no reason to write that whole thing down. We're just going to leave it as ln 6, okay? And then divide by 0.6, 0.6. So then x equals ln 6 divided by 0.6, okay? All right, now these two guys don't have the same base. It's not a base 10, so we're going to use ln on both sides. So ln of 5, x minus 3, ln of 4, 2x plus 3, x plus 3. Okay, so then your power, remember, actually comes to the front. So then this power would also come to the front. So now I've got x minus 2 ln 5, 2x plus 3 ln 4. Okay, then I'm trying to get my x's by themselves. So the next thing that I can do is rewrite this as two problems. Okay, so I can rewrite this as x ln 5 minus 2 ln 5 equals 2x ln 4 plus 3 ln 4. All right, and then what you'll notice is I can take out and, oh, I forgot some, oh, there's the x. Nope. I almost forgot something. Oh, I'm going to combine. So what I'm looking for, I worked this earlier, is I'm going to put the ones that have an x together and the ones that don't have an x together. So I'm going to move 2x ln 4, negative 2x ln 4. And then I'm going to, do I have another color? Yep. Then I'm going to move this guy over to that side. So then I'm going to add 2 ln 5, add 2 ln 5. Okay, so now that'll make that x ln 5 minus 2x ln 4 equals 3 ln 4 plus 2 ln 5. Okay, then I can take an x out of both of these. So then I have ln 5 minus 2 ln 4 equals 3 ln 4 plus 2 ln 5. Okay, then I can divide, because I've almost got x by itself. So now I can divide, oh, sorry. I can divide ln 5 minus 2 ln 4, ln 5 minus 2 ln 4, and I end up with x equals a very long problem. 3 ln 4 plus 2 ln 5 over ln 5 minus 2 ln 4. And that's my final answer. Okay, this next one, I'm not even sure how I'm going to fit this in. Okay, I'm going to work on factoring. If you think about what are all the things that would multiply to give you 3 that would add up to be negative 4. Okay, so it's going to be kind of crazy. So I'm going to do e to x, or not 2x, ex, and then ex. Okay, then how can I get a positive 3, multiplying to get a positive 3 that would add up to negative 4? Well, I could do a negative 3 times a negative 1. Okay, then each one of these I'm going to set equal to 0. So e to the x minus 3, set it equal to 0. E to the x minus 1, set it equal to 0. Okay, then I would add 3 to both sides. So I get e to the x equals 3, add 1, e to the x equals 1. Okay, so this one's pretty easy because anything to, well, actually, let's do this. If I do ln on both sides, so ln on this side, ln on this side, ln on this side, ln on this side. Okay, so e and ln are going to cancel each other, so that's going to leave x equals ln 3. And then ln and e cancel each other, so that's going to leave x equals ln 1. And Another thing, ln1 always equals 0, so actually x equals 0. Okay, ln1 always equals 0.